So in this note sheet, we're looking at the ideas of simple interest and percent change. So our first question looks at, how can I use a formula to calculate the simple interest on an investment or a loan? And how can I find the percent change between two data points? Both of these topics use formulas. And so basically what we're going to be doing is, once we know what the letters in our formula is, then we can just use our formula. So first we look at the interest. So what is simple interest? Interest can be two different things. Interest can be the amount of money that you make on an investment. So essentially you're making money doing nothing. Okay, you put money into a bank account, you let it sit there. When you go to take the money out of the bank account, there's more in there. Okay, you're making money just by having it sitting into an account. Interest can also be something that's kind of negative. Interest can be the extra amount of money you have to pay on a loan. So essentially, you have to pay money to borrow money. So a lot of times with car loans or a house loan or credit cards, you end up having to pay back more than what you borrowed. Okay? And that extra is the interest that the bank or the credit card company charged you for letting you borrow that money. So what is the simple interest formula? The simple interest formula says I equals PRT. I don't ask you to memorize much, but this formula right here is one that you will need to know for your test, and it's not on any formula sheet. So you're just going to want to make a special note to get that memorized. What you'll notice in this formula is you have 4 different letters. I equals, and then you have PRT. And there's no space in between these variables. What that means is that these are all getting multiplied by each other. So there's little multiplication symbols within this formula. But first let's start by figuring out what each of these letters mean. I represents interest, the thing we were just talking about. This is the amount of money that you make from the investment or the extra that you have to pay on a loan. P represents the principal. And this is not the principal like Mr. Miller. The principal in terms of interest is the amount of money that you invest, or if it's a loan, the amount of money that you borrow. Okay, so I is interest, P is principal. R represents our rate. Our rate. With all of these questions, since we're talking about interest, it's going to be a interest rate. And so the only tricky part with R is that they're going to give you a percentage. What we need to do, however, is we need to turn that percentage into a decimal. So whatever number they give us here, we're going to have to divide that by 100 to turn it into a decimal before we go and plug that into our formula. T represents our amount of time. And so this is always in terms of years. Okay, so they'll tell you 4 years, 5 years, 8 years, 20 years. Okay, they'll always give you an amount of time in terms of years. So now if we actually look at some of these examples, we can use this formula to figure out our answers. You'll notice that there's 2 boxes here. That's because whenever we're solving problems that use a formula, we want to make like a little shopping list. Okay? Our formula says I equals PRT. So we're going to want to make sure that we make a little shopping list of our variables before we go to plug these into the formula. So let's look at this first example. Timmy opens a savings account with $100. If the bank offers a simple interest rate of 5.4%, how much interest will he receive after 6 years? Okay. He opens the account with $100. They offer him a rate of 5.4%. They want to know how much interest will he receive after 6 years. So our I is for interest. How much interest? We don't know, so that's our question. P is for principal. How much money did they start with, or did they invest? Oh, well, he opens the account with $100. R is our rate of interest. Oh, well, that's 5.4%. But remember, we need to take that 5.4, divide it by 100. 0.054 is the decimal that we're going to need for our formula. And then if we look, 6 years. So our T is 6. Now when I go to use this formula, I equals PRT means P times my R times my T. And I'm just multiplying all of those numbers together. 100 times 0.054 times 6. Find that the interest is $32.40. So in this example, Timmy made $32 in interest, meaning he made $32 just by investing that $100. Let's look at our second example. Again, I'm going to write out my variables. Marcy started a simple interest account with an interest rate of 3.8%. If she invested $500, how much money will be in the account total after 4 years? I'm going to put a box around how much money in the account total. That total is going to be a really important word that we look at here in a minute. But let's think. We don't know how much interest. Well, the principal, what's the amount that she invested or that she started with? Oh, that's 500. Our R, it's not 3.8. Again, we've got to take that percentage, divide it by 100 to get the number for R. And T is our time in years. Our T in this case is 4. So now we can go ahead and use that same formula. I equals P times R times T. 500 times 0.038 times 4. And we get 76. But let's go back to what that question's asking for. That question wants to know how much is in the account total. This is just the interest. So let's think. She earns this much interest, but she put $500 in the account to begin with. That $500 is still there. So when that question asks us for the total amount in the account, it's going to be the $500 that she started with plus the $76 she made in interest. It's for a total of $576 in that account. Sorry, I'm off the page. So it's just really important and really crucial that you take a look at what the question's asking for, because sometimes they'll want to know just the interest and sometimes they'll want to know the total. So what I want you to do now is to take a second, see if you can read through this question, make your list, and solve it on your own. So pause the video, take a chance to answer this question all by yourself. What you should have done is when you went and read through this question, you should have said, oh, okay, a simple interest loan of $6,500, 4% interest, and how much will they pay back total in 6 years? Over here, when you made your list, okay, you should have not known your interest. The amount that you borrowed was $6,500. Your R, 0.04, because remember, we have to take that percent, divide it by 100. And for T, you should have had 6. So then over here, 6,500 times 0.04 times 6. 1,560. If you stopped here, you were able to find the interest, which is great. But again, if you look back at that question, they want to know how much will you pay back total. Since they want that total, we had to have gone back. Okay? They borrowed $6,500 for the car, and then they have to pay $1,560 extra because of interest. I know that might not sound fair, but that's how it works in real life. So they end up paying back not just $6,500 that they borrowed. They actually end up paying $8,060 for that loan because of the extra added interest. And so those are just a couple problems on simple interest. Okay. You have a homework on it. It's on your study guide. There's an activity that you can do. There's lots of opportunities for you to practice. If you need help, again, please, please, please stay after school with me or ask questions in class, to understand how to do this. Right now on the back, we're going to flip it over and look at percent change, but this is all simple interest. Okay. So let's start with what is percent change. Percent change just describes how much something has changed compared to what it used to be. Okay, so a lot of times you might hear on the news, the price of oil has increased by 26%, right? They're not saying that the price increased by $26. They're saying that it increased by 26%, meaning that percent is compared to what it used to be. A lot of times when you give something as a percent change, it can sound a little bit more dramatic or extra and kind of makes your point a little bit better. So if you have a percent increase, what that means is that the percent change is positive. It has gone up. If you have a percent decrease, your answer is going to be negative in terms of percent change because it's gone down. It's a pretty simple concept or a pretty simple idea. Now the formula, when we find percent change, again, this is not going to be on your formula sheet, but you do need to know it for your test. If you can remember the word no, you'll be okay. The formula to find percent change is new minus old divided by old times 100. Another word that you could use instead of old is original. So sometimes it might be easier to think of it as an original number versus an old number. But this is the formula. Another kind of annoying piece to this is that on your calculator, if you don't hit the equals button enough, you'll get the wrong answer. So you need to hit the equal button 3 different times. New minus old equals divided by old equals times 100 equals. Okay? I know it sounds silly, but again, you're going to get it wrong and you're going to be really confused and upset, and then I'm just going to tell you typed it in wrong, and let's just avoid all of that. So let's look at a couple of these examples. In May, the average, temperature was 78 degrees Fahrenheit. By the end of August, the average temperature was 92 degrees Fahrenheit. What is the percent increase in the average temperature from May to August? So let's think about it. We have a new and an old. Between May and August, which one would be the newer number or the newer value? That would be August, or the 92 degrees Fahrenheit. Okay? If you think about it, new is the one that comes after. Okay? August comes after May. That means that our old value is 78. So when we go to plug these into the formula, 92 minus 78 divided by 78 times 100. So here in my calculator, 92 minus 78 equals, well, that's 14. Divided by 78 equals, times 100 equals. I get 17.948, blah, 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 blah. So we're just going to round that off. I'm going to say 17.9%. Or I could have said 18%. Either one would have worked. Let's look at that second example. What is the percent increase in the market value of a house from 2009 to 2010? 2010 will be our new value, 2009 our old one. So let's go and plug these in. 418,500 minus 363,000 divided by 363,000 times 100. I know that's a lot of zeros. So here we go. 418,500 minus 363,000 equals 55,500. Okay? Divided by 363,000 equals times 100 equals, and I get this, 15.289, blah, 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 blah. I'm going to round that off to 15.3%. Okay, that 8 after the 2 would bump that up to a 3 if we're rounding it. So let's look at this third example. Let's see if you can do this one by yourself, okay? See if you can do it ahead of me. During his first week of marathon training, he could run a mile in 8 minutes. During his third week of training, he could run a mile in 6 minutes. So what is the percent change in his running times? What's the new value? What's the old value? The new one is the one that comes after. So it's not going to be from the first week, it's going to be from the third week. So our new value is 6. Our old value is 8. So let's see if you can set up the formula right. You should have 6 minus 8 divided by 8 times 100. If you plug that in right, you should get negative 25%. And it's okay that our answer is negative. If you think about it, it went down. It started at 8, went down to 6. That's a decrease. Okay, where our answer is going to be negative in terms of percent change. That's okay. It just means that it went down. We have one more example, and they tried to trick you a little bit with this last one. It says that a manufacturing company with 450 employees begins a new product line and must add 81 more employees. What is the percent increase in the number of employees? So we have a new and we have an old. It says that they have 450 employees, but then they have to begin a new product line and must add 81 more employees. So the old amount of employees is 450. That's how much that they used to have. But then they have to add 81 more. Our new number is not 81. They had to add 81 more. So it's the 450 that we used to have plus the 81 new employees, or 531. So that's where they tried to trick you. They gave you two numbers, but you actually had to do a little bit of extra math to get that new number. So now let's use that in our formula. Our new number, 531, minus our old, divided by our old, times 100. 531 minus 450 equals, divided by 450 equals, times 100. And we get a nice 18%. Okay? Again, you have some homework, you have a classwork activity that you can use to practice this percent change, but please come and see me if you have any questions.